Now we're going to start discussing prevention minimization, and on this section what we are going to do is we're going to identify what are the sustainable options for waste management. The sustainable options that we are going to discuss now are recycling and composting and energy recovery. Energy recovery through incineration and energy recovery through methane anaerobic digestion. That's a process that leads to biogas production. So the first two options that we are going to discuss is recycling and composting, which relates to recycling or reuse of materials as well. So recycling is an ideal option for plastics, non-ferrous metals, aluminum, glass, and cardboard paper, but we can apply recycling for other types of materials. The main advantages is that it conserves 3 to 5 times more energy than waste to energy. And this is because imagine that we are actually reducing not only the amount of, we are reducing a good that actually we're not using any more energy for doing this good. We also have as advantage the reduction of greenhouse gas emissions, the reduction of air pollution and water pollution, and the conservation of natural resources, of course, because we are stopping the extraction of this material, for instance, let's say paper, and it contributes to the creation of jobs. The main disadvantages are that the recycling is subject to the market. So if no one wants the material, then it will be piled and no one will need it. And this is the case, for instance, for glass. Glass is being recycled, but there is no market for the use of for buying glass. We need for recycling high upfront capital cost, and the recycling sites are not always a hygienic place or safe. So these are some of the disadvantages. Composting is something that can be applied for food waste, for wood, for paper, and for green waste. The main advantages is that it decreases soil erosion by enhancing soil structure, improves the physical properties of soil, reduce watering needs for improving water retention in the soil, and you will still emit greenhouse gas through CO2 emissions, but this will be CO2 emissions instead of having methane emissions. And methane is a stronger greenhouse gas. Some of the disadvantages are that we need to have some requirements of waste, also moisture content, and we need carbon to nitrogen balance. We need oxygen transfer in high amounts, and this may require the addition of energy for transferring the oxygen. Particle size is important, but some of the main disadvantages is that the waste may contain inhibitors or also things that can contaminate the soil, for instance, heavy metals. Also, the nutrient value of compost is low compared with that of chemical fertilizers, and sometimes these fertilizers are cheaper than making compost. And also transportation cost is a problem for handling the compost. So now we have what is called waste to energy. And for waste to energy, we have incineration and biogas production. The preferable composition or the preferable waste for incineration are paper, plastic, textiles, leather, and wood. Any organic material that contain low amount of moisture, it's the most preferable. These are the best options. The main advantages are that the landfill space is greatly reduced. No wonder why European countries prefer to have incinerators rather than landfills. In this line, it reduces waste volumes to up to 80 to 95%, produces electricity and heat, and eliminates the problem of leachate. The disadvantages are that it requires skilled staff to run and maintain them. The waste has to have a low moisture content. Also, carbon to nitrogen must be balanced, and smoke and ash emitted includes acid gases, nitrogen oxide, heavy metals, particulates, and dioxins that may be cancerogenic. The reuse of produced energy needs to be established, otherwise it's wasted. The facilities are expensive to build, operate, and maintain. So now I'm going to discuss biogas production. These are the ideal options for wood, food waste, paper, and green waste. The main advantage is the generation of biogas and fertilizer, the reduction of greenhouse gas emission through methane recovery, and the reduction of solids to be handled. However, it also requires skilled staff to run and maintain the digesters. We need to establish also the reuse of the produced energy, and also since we are dealing with bacteria, we need to take care of the amount of chemical compounds that can inhibit methanogenic and other type of bacteria that are needed for degradation for biogas production.